2.8, graph and linear and absolute value inequalities. So most of this lesson is actually just for review. Only thing we're going to add is how to graph inequality, which I think most of you guys kind of did already. So there's really two things you need to worry about with inequality. And one line. So for the line, it's either going to be less than or greater than, no equal to sign. So in that case, we're going to draw a nice dashed line. And that means you cannot be the line. So like that's equivalent of saying like an open circle, right? You can't be that value. And then we're going to have greater than equal to and less than equal to. For that, we're going to draw a nice solid line. And that's equivalent to saying a closed circle, right? You can be the line. So it's very simple. If you see a line, make it nice and solid. If you don't see the line, dash. Now the other part, the second part of this is shading. There's actually two ways of shade. So first you got to worry about, is it less than or less than equal to? In that case, now there's two ways to do this. And the first way is if it's in proper notation. So proper notation is like y equals mx plus b. In that way, then we could do a little shortcut. I give you a line and I say I want you to shade less than it. Well, then it's just natural. Like less than the line would be below the line. So you shade below. Again, this only works when it's in proper notation, where the y is the variable is on the left hand side. So it only works in proper notation. And then the other side would be greater than or greater than equal to. Well, if you're greater than the line, you should naturally be above the line. So above. That's supposed to be a different color. Sorry. So above. But again, both of these ways only work when it's in proper notation. So that's a shortcut. If it's in proper notation, less than means below, greater than means above. Makes sense. But if it's not proper notation, what's the way that always works? We can do what's called, you pick a point. Pick a test point. So this way it always works. It doesn't matter what notation is. So you pick a test point. So best way to do this is to show you by example. Let's just say I have a line that looks like this. That is y is has an inequality greater than. That looks like, let's say, x plus 2. Now I wonder if I want to shade above or below this. So the way that always works, it's a little more work, but it always works. So you pick a test point. So you pick a point like, let's say 0, 0 is probably the easiest. Now it can't be on the line. So if 0, 0 on the line, I can't use it. And you plug it in. Simplify, I got 0 is greater than 2. That does not make sense. That's a false. So I'm not going to shade this. I'm going to shade the opposite. If it was true, to shade it. So that's how you pick a test point. Pick a test point, plug it in. If it works, shade. If it doesn't work, shade the opposite side. So again, that way it always works. If it's in proper notation, you can use a shortcut, greater than, less than below, greater than above. But no matter what, pick a point always works. Other than that, that's something new. Everything else is just, let's do some examples. Let me add a little chart there. Okay, that's fine, I guess. Let's make it black. There we go. Come on. Come on. Okay. Now let's graph this thing. So 3x plus 2y, again, if I want to graph a line, you want to get the y by itself. So subtract 3x from both sides to get 1/2. Y is less than negative 3x plus 2. Ooh, one thing I forgot. I'm not going to do it now, but don't forget, for inequalities in general, if you multiply or divide by negative, you have to flip the sign. So don't forget that, in case that comes up. Anyway, I have this. Now I got to multiply by 2, get rid of that 1/2. So multiply everything by 2. And I get y is less than, distribute, negative 6x plus 4. So y is less than negative 6 plus 4. Graph that. Plus 4. Go down 6 over 1. Since that effect. This is a dash line. I don't see an equal to sign. So it looks like that. Again, two ways to shade this. You can either, it's in proper notation, so less than should mean below. Or you can pick a test point like 0, 0, plug it in. 0 is less than 4, so I shaded the right area. So again, just graph it like normal, and then shade above or below, or pick a test point. Next one. Again, let's solve for y first, so add x 2y is greater than x plus 4. Divided by 2, we're going to divide everything by 2. So y is greater than 1/2 x plus 2. I want to graph this thing. Plus 2. Down 1 over 2. Oh, sorry. Right, the positive 1/2, we're going to go up and over 2. Up 1 over 2. Again, no solid line, so another dash 1. And again, proper notation, so I can just go, okay, greater than to above. So now you can pick a test point. And you can pick any test point. I've been picking a lot of 0, 0. I'm gonna pick, let's pick 2, 0 to check it out. So plug in 2. In this case, I get 0 is greater than 3, which does not work, which is why I shaded the opposite side. So again, either way works. Either if it's in proper notation, you just go less than below, greater than above, or test point. Graphing absolute value inequalities, nothing changes, same idea. Nothing changes here, right? The only thing I would say is if it's same idea. If it's in proper notation, less than is shade below, and greater than is shade above. If you're not sure, you can always do a test points. Nothing else changes. So let's do a couple of examples of practice. Plus 3. So remember, I'll move it up 3. There's a vertical notice on the outside, so it's a vertical stretch of 2. Could treat that like a slope. I'm going to go right 1 up 2. Left 1 up 2. Solid line, so make that solid. Now it's in proper notation, so less than means below. But again, if you're not sure, pick a test point. Let's pick 0, 1. Plug it in. So 1 is less than 2 times 0 plus 3. 1 is less than 3. That is true, so I did shade the right area. Alright, so either way it works. Next one real quick. First step is go plus 6. The y by itself. So y is less than value x plus 6. On a graph that, go to 6. Shift to slope of 1 and 1, so kind of like normal. And less than, so shade below. Ooh, an application problem. Greg needs to buy gas and oil for his car. Gas costs $3.45 a gallon, and oil costs $2.41 a quart. He has $50 to spend. Write an inequality for a present situation where G is the number of gallons, and the gas he buys, and Q is the number of quarts of oil. So in this case, let's look what's going on, right? So they say G is the number of gallons, and Q is quarts of oil. So for A, it's $3.45 a gallon, so times G, and it's $2.41 a quart times Q. Now in total, you could spend $50. So if I add these up, it has to be less than $50. So that's my inequality. B wants me to graph it. So if we're going to graph this on the XY chart, well, I don't have X and Y, so I'm in G and Q. Just solve for one of the variables. Let's make this like our X, like our Y. So we're going to solve for Q. So 2.41 Q equals less than negative 3.45 G. Subtract that from both sides. Plus 50. And I got to divide by 2.41. That's not going to be pretty. And I'm going to get Q is less than or equal to whatever that is, plus whatever this is. They want me to graph it, so just graph like normal. Go there first. That's about like 20-ish. There somewhere. Slope of that, I'm gonna go down 3 over 2. You get this less than, so shade below, so it's side effects. Can Greg buy 10 gallons of gasoline and 8 quarts of oil? Explain. Well, easiest thing to do there is just plug it in. Plug in 8. Sorry, wait. Gas is 10. Plug in 10. Plug in 8. See if it fits. I'm gonna use my calculator in this case. turn it on. I always forget to do that. Just clear that. So 3.45 times 10 plus 2.41 times 8. I get $53. So no, right? That's more than 50 bucks. So no, you can't. So that's one way to do it. Another way to do it is if you go to 10.8 on your graph, 10.8, you'd be like up here, and it wouldn't fit. So you notice it's outside the circle range. If they said something like, "Oh, could you buy 1 quart of gas and 1 quart of oil?" I'm like, "Oh, yeah, that's inside the range here." So 2 ways to do that. And that's how you do an inequality problem, right? So you set up your equation. So you want you to graph it, solve for one of the variables, then graph it like you normally would. And there's 2 ways to do it. If they ask you a question like that, 2 ways to do it. One is plug it in, see if it works. It's probably the easier way. Otherwise, let's look at your graph. Does that point they give you fall within the range? If it does, then yeah. If it doesn't, no. And that's it.